morning, everybody. So, happy to be here at any time to dig in for questions. I know there's lots of questions about the airplane. If we can't answer those here, please come to the booth. We'll have further time through the week to answer your questions in detail. So, engineering insights. So just talk about the mission of the airplane. This is the high wing that is worthy of carrying the RV name. That was stated in yesterday's presentation. Just to raise a hand, how many were here at yesterday's presentation? Okay, most of you. So I won't cover in detail the slides that we covered yesterday, but we really did feel when we were laying out this airplane, you wanted to bring the RV experience, the RV control handling, to what it meant to be a high wing. I've flown a number of highways. I learned to fly in a J3 Cup, so I started there, and I knew what an RV could bring to the market. We cruised at 182 as a land Cup, so that total performance, we wanted that slow speed, but we wanted a reasonable cruise speed at the same time. And an airplane that you could land hard and would be easy to land and keep that safety metric up that we're known for is RVs. So typically insurance on RV is something you don't think about when you build a kit. It's reasonable and on par with the certified market. One way we keep that way is we design safe airplanes. So you'll see a lot of that in today's presentation. Predictable, safe flight characteristics. And of course with Mosaic coming out, at least initially, it is Mosaic compliant, and that introduces something called ELSA. And under ELSA, there's no 51% rule. So what we're able to do for you with this kit is going to be next generation advanced aircraft. The final performance numbers will not be out until we have the final fuselage. So those of you who see the airplane in the booth, notice the camouflage wrap on the fuselage. The fuselage will eventually be replaced. We're working on the final version fuselage. That's going to move the wing 4 inches back, and the engine will move about 1.5 inches forward. The useful load, though, from what we know so far, the useful load, we will obtain 900 plus pounds. Now, the limiting factor there is going to be the horsepower available and the performance of the aircraft. So if we go above that, it's going to be dependent on probably a limiting in the envelope dependent on that horsepower available in the outside weather conditions.
Look in there and find my mouth.
Stall speed and gross weight is going to be under 45 knots 30. We can tell you that we're also easily achieving that at this time. Top speed with the small wheels is going to be, we're going to be able to achieve 140 knots. So we're close to that now. We have a lot of drag reduction to do on the airplane. Those of you that have been around the airplane can see there's no upper intersection fairings. We're going to redesign, we'll get into it later, how the landing gear work and slightly the shape from a shape perspective, and that'll help. Both Brian and I have been flying the airplane and are able to easily take off and land in under 400 feet. So we know we can achieve that. And lightly loaded performance is better than that. And those of you that have been watching the videos we put out,
I think I found it.
You'll be able to see that we landed under 400 feet. Yeah, go ahead.
So I know it's a little frustrating. We've got these performance numbers that are ranges or pluses or greater than, less than. We want to give you a number that we have absolute confidence in. So the airplane, we know what it does today precisely. We know where it's made concessions and where it will improve. And we don't want to give you a number, a design target that is not absolute fact. When you see an RV spec sheet, you have confidence that that is the number your airplane will hit. So bear with us as we develop the final airplane, which is truly just clean it up. The bearings and whatnot, seal the air gaps, get the proper doors on it. And beyond that, we may think about, oh, this landing number, that's not that aggressive, but keep in mind we're engineers and we're working towards a design standard, so that is all adverse CG condition, adverse loading condition, that standard temperature days. I mean, we're getting numbers that the guy that's showing off in his whatever airplane is not using. This airplane is very, very impressive when it's live, just like most of the RVs are. So we're maintaining this strong performance target in these more conservative conditions. And we're very confident that we'll exceed these numbers, and can't wait to tell you the real one as the real fuselage flies late this year.
definitely. So the last number on this spec sheet we have up is horsepower. If you think of this airplane in the future in the flight school market, they wouldn't want to be above 200 horsepower. So having the airplane under that, 0360 A1A, for example, 180 horsepower, that's about a 285-pound engine. There's lighter versions of the 0360. Got the main turned up pretty high there. I'll try to get closer to the mic as well. So we had there are versions of lighter weight engines that you can get in the parallel configuration. Some of those get as light as 255. We're shooting for the 265-pound to 270-pound range. So that would be the lightweight engine. There will be a limitation on baggage. You'll probably lose about 50 pounds of baggage just due to the weight and balance considerations with the lighter engine. If we look at horsepower, though, a lot of you are going to wonder about the, come back here, there we go, about the Rotax 916. It's a popular engine, but I'd just like to go through our engine choice and how we got to the point where we are with the IO390 EXP. So in reality, the Rotax is an engine, if you look at power to weight ratio, at only 160 pounds or 160 horsepower, you get that for the first 5 minutes. After the first 5 minutes, you're going to be at 137 horsepower, and the question is, are you out of the canyon yet? And if we look, I'll show you some charts here that further prove our decision. But the IO390, it started as the C model used on the SR20 from Cirrus. We took that engine, worked with Lycabig to not only put a cold induction on it, weight reduction with that engine, but we also designed a specific induction flow snorkel system that actually boosts the manifold pressure by 1.3 inches. So we're getting about 218 horsepower out of that engine. So what I'm showing here is backcountry strips. We looked at 156 strips in the Idaho backcountry. 85% of those are 5,000 feet below. So let's take Johnson Creek that we're all familiar of. And what you see in the center of the slide there is that the hottest that Johnson Creek gets is around 90 degrees. And a couple of days ago before the show started, sure enough, it was in the upper 80s, about 88 degrees. Johnson Creek, 5,000 feet at 90 degrees, the hottest part of the day, that's where a Lycabig becomes equivalent to a Rotax 916. So it's only above that that you'd have a slight advantage, and then only for 5 minutes. So if we look at the charts, this is the Lycabig chart, you're going to see that after 5 minutes, you need to be above 13,000 feet to get that advantage. So we felt that for most of the airstrips, you're going to have a lot more horsepower to get off the ground with the IO390 than you would with the 916, the Rotax 916. And really, we need to think about the future, what's going to happen in the future. Engines are only going to become with more horsepower available. And we feel that this airframe will be around for an extended period of time and be able to take advantage of that. So if we look at, this is a chart that we actually, this is way back about 2018 working on Mosaic with the FAA. It's really a chart of power to weight ratio. So if you're below that black line on power to weight, you're kind of anemic airplane. You'll see the Cessna 172, I think a lot of people have probably trained in one. Not much performance there. So if we look at the chart, the blue line is where the IO390 is lying. And the orange line is what makes an RV. You'll notice that an Extra 300 is above that line, but pretty much all the RVs lie on that line. So if we would have chose a Rotax 916, and I'll just go over here and point since I don't have a pointer. We would have been in this range right here. That's well below the performance range of the Rotax 916. Now, if you think of putting 4 people in the airplane, really where you need to be in a 4-place airplane is about 260 horsepower. So I don't know if you see the RV-10 up there, but the RV-10 has 260 horsepower. You need that the 6-cylinder engine with the extra horsepower to really get 4 people off the ground. So with that said, that's where we came to the conclusion that we're really bookended between the Cessna 180, which we'll talk about today, and the lighter weight airplanes that had smaller engines, they're wanting to get larger. They're wanting to have more baggage space, larger engines. We felt that we filled a space right in between that wasn't being filled in this part of the market. And really, if you go back to what makes an RV, that's what we did. If you look back at the two-seat RVs, we took engines off of 4-place airplanes, put them on a two-seat RV, and you have amazing performance. So we felt that we hit the sweet spot. If you look at a Cessna 180, you load it with 4 people and 60 gallons of fuel that the original 180 had, there's no room for baggage. People fly in the Outback with 2 people and baggage, and their friend flies their airplane with 2 people and baggage. So it's that sweet spot with the affordable 4-cylinder engine that we were trying to achieve. And with that, I'll turn it over to Brian here for a few slides and talk about the visibility in this airplane.
Yeah. So as we were working through, like, what do we feel like people would want to know about this airplane? What are the attributes that we really laid out, that how we wanted to start drawing this airplane, get it to balance, and how it's useful, what we can put in it. And one of the key ones we kept coming back to, and we've flown quite a few experimental high wings, certified high wings, the 180s, the Glass Air Sportsmans, and something we really felt was lacking is the general visibility in the airplane. So the side visibility is spectacular with the big door glass, but also the over-the-nose visibility. So this airplane, it really gives the impression of a tricycle type visibility profile. Now it's a bit of a step to get in it, and we will have a step, but it is so confidence-inspiring being able to not only taxi and see where you're going, but approach and land the airplane in a very flat, level attitude. You'll notice that this backcountry airplane has not made these design concessions of slats or PGs or what have you. That's a very intentional decision to really wing the airplane properly and build the most efficient flap we possibly can to keep the airplane flying in a fairly level attitude, even under power-on approaches, dragging the airplane in. You're never at this point where, the next 20 seconds I don't know quite what's going to change and what's behind the nose, but I'm committed. This airplane, you're always conceived, you have plenty of power to initiate and go around, and you're just landing the airplane like you would any tricycle type airplane.
Visibility is the same in this airplane with the 26-inch tires, roughly, that the RV-10 has in its tri-gear configuration. We did an interesting study. We watched airplanes spot land at the Valdez competition, and the only reason that you get a slower speed with VGs or leading edge slats is because you're at a higher angle of attack. When you're at higher angle of attack, you can't see what's in front of you, especially after you land on the rollout. And those airplanes that were coming in at a lower angle of attack actually were doing better spot landings and winning that competition. So that drove our design decision in this segment. So we made a number of changes to the fuselage. One of the reasons we had the fuselage blacked out is due to the fact that we have fuel lines crowding down the A-pillars, we have a rusty flap handle, we have, you name it, cables inside the fuselage that will be hidden in the final version. And we just didn't want to show that to you. There's a number of changes that are coming up that we're now completing into the final fuselage before we build that fuselage later this year. And Brian, why don't you go through the list?
As it sits today, it's very much an engineer's type of airplane. It's been modified, hacked on, drilled. There's old structure that's no longer used anymore, and that's very much just, let's get the airplane flying correctly, let's get through flight tests. And we've held this airplane to such a high bar that that's been a big focus, and that's truly the design challenge with any RV. Getting the touch points understood, getting the structure in the cabin and whatnot, that doesn't affect how the airplane really feels and flies. And that's a fairly straightforward design process, and that's been going very quickly in this airplane, especially with our prototype, our REV-1, to use as a basis, copy off the homework and redesign the few misses we had here and there. Maybe that's a little manufacturability thing, or combine these 2 parts into one, or maybe we shouldn't machine that. Let's evaluate, a folded assembled piece. Now that is what we're doing as we move towards this fuselage structure. It's a huge milestone to be past how the airplane flies and what the hinge homes are, which is what we think of as the progressive feel of the sticks, being light in the center and progressively working up the forces on the stick. These are all the subtleties that an RV has always had, but it's very noticeable when you just hop into another airplane. Something we really think about a lot is we don't want a pilot to have to learn the airplane, make concessions to the airplane, or compensate for an airplane's deficiency. There are many airplanes that I've flown like that. Maybe it takes 4 or 5 hours and you figure it out. But we didn't want to hold ourselves to that. We're going to hold ourselves to a higher standard, have the airplane truly fly right, tune and adjust until it's just correct. Now, with that said, the new airplane, we still don't have a baggage door. We took the sticker off. We definitely had feedback there that's going to grow, and we're very excited to show that off as it goes into the next airplane. The control stick position, it works, but we have ideas. We're going to make it clear the legs just a little better. The width of the fuselage is going to grow about an inch. So right now we are at 46 inches. And the instrument panel is a little close to your knees, the seating positions. We didn't fully consider the range of people, but tweak and adjust to make the airplane handle correctly. It still has the Cessna seats. All of these things are considered and deep into the design phase, if not prototype. We've got a really slick adjustable seat that we've been sitting on and playing with, and there's some revisions to make, but I think we'll be very excited to see that. So from there, we could talk all day about what's next. We got quite a few slides.
Yeah, hopefully those answer some of your questions.
Yeah. And I can certainly talk airplanes all day if you find me later in the day.
For some reason, I'm not.
I guess I'll keep talking.
Let's see. Current slide.
Here we go. Yeah.
So the room. Yeah, this is. Anybody seen the Constellation yet?
Yeah.
It's right next door to us where it was being repaired. And this is Luke. He's responsible for repairing the Constellation. Conveniently, he's 6'7". So as you can see, he still has cushion there underneath him. And you can see that Van and I fly with a similar cushion set to Van, have quite a bit of cushion underneath us. So there is a lot of room in this airplane to take taller pilots. And why don't you explain what's happening in the fuselage area? Changes.
Yeah, so pilot positioning, it's a little, especially the knees, and people are very proportioned differently, torso to inseam and whatnot, and it's a bit of a design challenge to work through. And as we finalized kind of the sight lines of this airplane, where we wanted people to sit, we did discover, the panel's just a little too close. There was a lot of RV-15 type inspiration in this, but it's more of a pedestal seat than a sit down and keep your feet up seat. And we're working through those changes. The panel will move forward and up. We're maintaining that visibility, so if you do have a chance to sit in the airplane, which we're on the next airplane, you'll see that there's it's the cowl cheek that is truly the limiting factor there. The instrument panel can rise and it won't change that nose visibility.
Let's talk about baggage.
This is putting the new wing on. Oddly enough, this was one of our biggest excitements. Of course, we saw it before we flew it, but we've always had a fuselage tank of some degree. We had the big old side tank that mounted to the seat tracks, and then we put an RV-12 tank in it. It really didn't sink in until we finally put the new wings on how big this thing really is. It is double a 14's depth. We can compare it to mini airplanes, but wow, is it huge. We had to stick the tote in because it almost makes it look like a miniature 55-gallon barrel with that picture. So, shown another way, people like to compare us to the Super Cub. Now the Super Cub, there's actually benefits to it. It flies well, it gets in and out really short strips, but it is slower and it's cramped. It's a tandem airplane. So Cub crafters, with their extended baggage option, that's 22.8 cubic feet, and that has bracing running through it, so you'll have to have a soft duffel and kind of work your gear into it. Our airplane, with no structure crossing the baggage area, just behind the doorpost is 44 cubic feet. We're approaching double, and it really feels it. It's very apparent. Now, shown another way, I know I organized the garage with these big bins. So those are the 27-gallon totes you get at Home Depot. That's what I use to go camping. That's what you have. And 6 of them, with room around them, fit in this airplane. 3 in a double stack. It's kind of hard to visualize. And if we put all 6 in them, people quite don't realize the depth of the baggage compartment. You don't see the last 2. So we came up with this little CAD model way of demonstrating that. Now, bicycles, that was one of the early things we talked about as a design challenge. I'm sure some people bring bikes, some people don't, but it's definitely an awkward thing to put in an airplane. And it was a very interesting design challenge to work through. So the length of a bicycle with that rear wheel, we will penetrate the plane of the baggage bulkhead slightly, but what we've done there is design a baggage bulkhead with the recesses for the wheel that will keep the bicycle upright, and you can just strap it back and keep the bike secure.
This slide's exciting.
Shown another way, it's like, I think of the 180 as a truck. It kind of feels like a truck when you fly it. It's big, it's a manly airplane. It just has that look to it. Now, this airplane, it looks like a truck when you're walking around it. It certainly does not feel like it when you're flying it. It is amazing how light and intuitive it is in the controls, how much control you have over the airplane. Turns around a point are spectacularly tight. We were doing these breakaways and rejoins, doing photo missions before, and just the spectacular visibility and control authority, it feels like you're flying the 14 in a lot of ways. So, and interestingly enough, so there's the 180. We do have a longer cabin than the 180 by 6 inches. And of course, airplanes are different. There's some odd things. We kind of lined up the floor and the wing. But where it's really apparent is in this top view. So we pulled that straight out of their VOH, scaled it, and plopped it on the airplane. This dark gray is the 15's cabin line, where the black line is the 180. We are substantially wider. Shoulder room, people are big, and people don't like feeling like they're touching shoulders pushed together, and it's very, very noticeable in this airplane.
So you might ask, how does it fly with all that cargo in it? You'll notice the tail is larger on this aircraft. There's a couple reasons. One, we wanted the pitch authority at slow speeds, but the side benefit, large tail, has a tail coefficient of 0.67, which is the same as the 180. And that gives you a lot of stability to FCG. I flew to Oshkosh at 32% just to play around with what AFCG would be. To give you an idea, that 180's affluent is 35% MAC, so that's a range that you can have a CG in. And affluent, an airplane might get squirrely. This airplane is stable in both landing and flight at AFCG at that 35% limit. So the wing move will help with that. Right now, we're about 26% back to that 35%. We're operating in shift that forward, so you're not always operating in the aft region of the aircraft.
Yeah, let me clarify. I guess another way to think about it is people talk a lot about like lightweight motors and we'll put a little bit here, we have to move the battery back. And being the designers of the airplane, the most powerful thing you can possibly do is just shift the CG range. Now, of course, most companies or most owners of airplanes don't have the power to do that. It's fixed, it's built off tooling. But especially this airplane, as we originally laid it out, and we are using structural weight estimations. We intentionally built it off of soft tooling.
Rally stabilizer.
Yeah, wood form blocks effectively, but knowing that we have an opportunity here to truly optimize this airplane to the ideal nominal empty CG position, effectively the forward limit, and build an airplane with the structure that perfectly balances as you load it, nothing left on the table, and we optimize that, of course, for that heavier weight by building 390. So there, the landing gear. We've spoken to it to some degree in previous forums, and this is still running off first generation landing gear design. This is modern suspension, it is energy absorbing, slow rebound, it likes to stick. Right?
One comment here. We really haven't recharged the gas struts. I know that was a concern, are the gas struts going to give up on us? We've left them the same way literally for years, every year. So we haven't touched it.
I went and checked the airframe logs. I was curious, how long have we just looked at them with no maintenance or no adjustments? It's been the last 200 flight hours, and we attribute a lot of that to having them in the fuselage. They're out of the sun, the O-rings don't have UV damage, they're protected, so these shafts that compress, they're not getting rock damage, they're not getting bugs on them. And it's just been a really clean way of handling this airplane. Now, with that said, we generally comment here that it's a lot of gear, especially flat gear, Cessna gear, even RV style gear. What makes a tailwheel airplane squirrely to be two things. The CG position relative to that gear, we can adjust and tune that placement and whatnot. But it's the stiffness, the lateral This gear is spectacularly stiff fore and aft and in torsion, so you never have this toe angle change under load or a sudden impact or a lateral impact if there is a lot of wind and you don't quite have it fully stabilized. This airplane, when you touch even crooked, it just tracks straight as an arrow and keeps going, easy to correct, it absorbs the event, and it takes this dynamic thing and doesn't create more dynamic, this energy return. It just absorbs and settles down when you touch the road.
I dropped this airplane in, I'd like to say on purpose. It was on purpose when it was about 5 feet. But you just drop it in, hold the stick back, and it settles down. So, if we're talking about a 180 again, it has spring gear. You have some cushion and energy absorption on the tires, but if you put energy into that spring gear, it's launching you right back up in the air. This airplane will take it, set you down on the ground, roll straight ahead.
Gen 2 landing gear. So there are a few parts of this. It is baking into the new fuselage, but the big changes we're doing is we have these gear towers that protrude on the current airplane. Those are effectively disappearing completely. There's going to be just enough room to get to the pivot point, get a tool on the pivot point, but no more. The next gear leg is going to be quite a bit lighter. We have a couple of clever little tricks that we are evaluating.
Airfoil shaped.
It will be an airfoil, so there will be no bearing on the gear leg. It's going to stay aluminum. It's going to stay stiff. Very excited to show you Gen 2.
Just like to give kudos to Brian here. He designed this gear. That's him with his first patent ever. So maybe a round of applause. It's well deserved. That is a genius design. The parallel link in the back makes sure that the caster angle remains the same. And I've never had tail wheel shimmy on this airplane. It's one of the precursors to ground loop. If you can stop that, you can go a long ways to stopping a ground loop condition. So just really quickly on the wing design, we're going to have deep dive videos from Mark Cook, so we won't go into this too much. So I'll cover these items really quick. Why a strut? Because you can make a lightweight airplane, and if you ever tried to push an airplane out of the bush, out of the mud patch without a strut. And so we did a lot of research. Ben and I were talking to people about this project, from 2000 onwards, and I remember way back then getting that feedback that, hey, I want a strut in the bush. Airfoil choice. This airfoil is again a Smith airfoil. He helped us, Steve Smith from NASA, that did the 10 and the 14 airfoil. It's a combination airfoil, so it gets the high lift coefficient of the 23,000 series. But we took some aspects of the Cessna airfoil, which has a very gentle stall on it, because you don't want a sharp stall break, especially if you have a longer aspect ratio wing. If you get a asymmetric stall, you don't want a sharp drop off. I've stalled this airplane at the ball not centered, and it still gently stalls straight ahead. In fact, Greg is on the back post. You helped me at that flight testing. Talk to him. He was the pilot. I was the guy videoing it. At first, there were the handprints on the dash, and then I realized that's not that bad. The controls. If we ever release the video, you're going to see my handprint on the first stall. Controls placed aft.
Yeah, so what we're trying to say there is, we're aware when you fly an airplane, especially in the wilderness, there's more likely to bump into things, whether that's bird or what have you. And we don't want any surprises. The aileron controls are all in the aft, and the flap controls, and that's not very common.
Aft part of the wings.
Maybe actually they're behind,
not the base cell.
Behind the main spar.
Behind the main spar. Protected by the main spar.
Many airplanes make a concession to put the flap controls ahead of it, but I'd be quite concerned, especially with a large flap of an asymmetric deployment, if you had a single side damage. So that was the design intent there.
The wingtip. If any of you get a chance, read a book called Wings for the World, the development of the Cessna series of airplanes, especially the first book. And it's written by the flight test engineer that was from like 1948 through the early 80s. Very fascinating book. And in that book, he talks about the droop tips from Cessna and what a joke they were unless you extended them down about 2 feet. So the droop tips don't really do anything for you. And going back to the days, the reason we have the shear tip is because it became popular with John Sharp's Nemesis Racer. and aftermarket started selling it. Really, the Horner tip is a more efficient tip. It's going to be just as efficient as the droop tips that you see because they really don't give you extra performance. So that's why we went with the Horner tip. The aileron and flap sizing, we sized the flap over the L19, the bird dog, to try to get, that was inspiration there, and then we knew with the large flap we needed a large aileron, so that came from the Helio Courier. And we'll get into more of that on the deep dives. But on the exciting things. So this is wing testing, which of course we've completed. It's 2 Mosaic standards, so there's a number of conditions. We also somewhat have applied this with FAR 23 as well, but Mosaic is +4, -2 on the G's. And these conditions are the dive condition, a maneuver condition where you'd be maneuvering the airplane at full roll. What that does is put a twist on the wing with bending moment. The dive condition is just a straight up bending moment that gets quite large. The gust condition came into play in the negative condition, so negative down if you're going to hit a negative gust. We also had to test for that. And why don't you tell us a little bit about how much weight is on this wing right now?
I want to point out, that's lead. Each of those bags is 25 pounds. The bag itself is about 1 foot by 6 inches. And there is a dramatic many thousands of pounds on a single wing. I'm still blown away at what it could really do, especially without permanent decoration. You know, that's one of the design standards. Does it not? I mean, this is absolutely a very robust wing, which RVs generally are. We do have a company design standard that meets and exceeds in certain places of different standards that we pulled that we like the intent of from around the world.
Yeah, we have 50 years of experience designing wings. Typically we design the main spar, for example, at a much lower stress level, so we do not have fatigue issues over time. You'll see that again on this aircraft. Just for time, I'd love to let you guess how much is on that wing, but it's around 9,000 pounds, just under 9,000 pounds. So that's full 2 Tesla Model 3s sitting on top of that wing right now. So about 19,000 pounds on the strut load right there. A full-size truck loaded is what's sitting on top of that wing in that photo. Brian had a lot to do with the main spar. You designed the main spar. It's a really lightweight design. Quickly, is there anything you'd like to mention?
So it's a folded sheet metal design. We're trying to keep the cost out of the airplane and retain full match hole. So you're not going to be drilling into big extruded caps. You're not going to have to taper or adjust anything yourself. And what we've done here is we've effectively made an I-beam with a front and aft sheet metal web and a center core that tapers in multiple directions as it works out. That center tapered core is 10 feet long. It is a big machine piece that is very inexpensive. You can crease on from the mill. They get cut out very easily. It's a simple taper. As we work through towards the point of highest bending, which typically in RV is the root, but in a strut-braced wing, it's at the strut, which did allow for quite a bit of structural efficiency and weight savings in this design.
So I'd like to talk about the tank just really quickly. We looked at the tank under all the previous loading conditions when we had weight on the wing because we didn't want a tank that would leak over time. So we're looking at deformations inside the tank. There's also a pressure test that's required. This is that pressure test being conducted for ASTM. And that pressure is much higher than you would normally see in regular operations. So you have to pressurize the tank, let the pressure off, it can't leak. The other test that you have to do is for the occupant safety standard under Mosaic, there's a inertial impact test. And right now, as of the end of last week, we were gone, but the engineers have kept testing. We've doubled over what's required under Mosaic for that impact inertial load, and we're still fine. So moving on to the fuel tank, again, 60 usable gallons. It's built as a separate assembly. It's going to come as a quick build tank standard in wing kits that you can buy today over at the booth.
No sealed surfaces on the spar. None of this high strain bending is on the fuel tank.
Yeah, people want a real picture of the tank. There's a baffle. The front is to the right in this picture. We're about to put on the top skin. So it's a tank modeled after the Cessna 206. There's hat sections in the bottom and the top, and that's to keep those skins rigid can carry a lot of loads so that you don't get fatigue issues, leaking rivets over time. There's also 4 access hatches. I started with the 206 hatch, and then I looked at the paw size of the humans that would be fixing rivets inside of it, and increased that even beyond that. So it's easy to access each bay. Anything would occur over time. Talk about the fuel capacity there for a second.
Fuel capacity, so we've really evaluated what's the use case of the airplane, what do we want to be able to do with it, where do we draw the line? So to compare, most experimental supercubs, the usable fuel capacity at best is about 39 gallons. We can flip through the POHs and look through that. The RV-15, we're at 60 usable. So it is the capacity slightly higher than that, but that is our usable fuel capacity at 60 gallons, near 50% more. Now, what does that mean? It's even higher with reserves. And you typically carry a little more reserve if you're out in an unimproved area. Now, this effectively on the spec sheet will create what looks like an excessive range. But really, when we're using this airplane, we'll potentially be headed off to an airport, an hour, 2 hours away with no fuel. Now, you can either make some concessions, stop somewhere off, and fuel left, go there, or go direct with this airplane and fly right back. You have dramatically more fuel than competitor airplanes.
In the Outback, a lot of the Cubs, it's less than 40 gallons. So this tank was it's actually larger than 30 gallons per tank. So we took out, the fuel cap's positioned pretty far inboard. If you're on floats or you just want to fuel from the tire, it's only 21 inches from the root out to the fuel cap. So you can easily get either a bag, if you are fueling from a bag, or the hose into the fuel cap. And it makes a difference. So that 60 gallons is going to get you into the bush, let you offload your camping gear, and then you can fly around and have fun at different strips and still get back out without using baggage capacity to carry fuel bags. We will offer extended range tank options in the future, but that'll be further down the list. I know a lot of you said you were here yesterday, so I won't talk too much about the plans pages, just to mention that they will be next generation. Less steps per page, more pages, and we're trying to simplify and really make it easy to breeze through the kit. And as we mentioned, there's the full-size plan page. Put more media in it. Mark Cook is with us now. He's going to be shooting videos. And as we mentioned yesterday, if you look at those wings, we had professionals build the tanks in the spar, but the rest of the wing kit that you would get, that was primarily, I'd say the control surfaces were by a multi-builder, but the main wing part there was built by people from the front office that had never built an airplane before. So go take a look, that's what it looks like. And again, we put those wings on, there's no rigging of the wings. Now, if you have multi-strut like an old J3, you have to rig the incidents, the twist in the wing and the alpha, and it takes a while. This was 1 minute 48 seconds to put those wings on, all 3 bolts, you're done, go fly. It's already set up. It's the beauty of matched hull. The fuselage is accurate, the wings are accurate. It's the beauty of what we bring to the home built world in advance. And then again, just to recap, you can build this with solid rivets. You'll notice a lot of access hatches on the wing. The reason they're there is for solid access riveting, but also we're going to include the wiring harness. You can put that wiring harness in at any time if you're unsure what you want to put out in the wing. Those access hatches allow you to just reach up in there and clip it onto clips. We're not putting harnesses through snap bushings on this airplane. They're onto clips, so we have claws in the front row. So you can pre-populate a harness with the big bulky connector on it and just drop it right into the airplane. Pre-dimpled holes, that's primarily on the nut plate locations on this airplane, in which there's quite a few. And you don't have to cut parts out of this wing kit, so there's no material you have to take out of the box, saw it to length, and then wonder about a few things, double measure. This is all going to be done for you.
No tapped parts.
So, to the flap system, and you had a lot of refinement here. Let's just talk about how it flies really quick.
Yeah, we went through about 4 iterations. The ultimate goal is maintain the stellar early performance and lighten up the flap forces. So the airplane was fairly functional. We had a couple of people in the airplane to help judge that. But we knew we could do better. We knew we needed to do better, truly. And what we've done is basically cut the flap forces by 75%. We
dramatic.
We put every effort we could to kind of game the system to make this an easy to handle airplane, something that didn't take a lot of attention, something that you wouldn't distract yourself with while trying to otherwise fly the airplane on the windsock, make sure there's not a deer on the runway, what have you.
There's a lot of sponginess in the first flap system because we had push rods that had to go from the base of the fuselage up to the flaps. We weren't getting full flap deflection, so that's why we went to cables, and we are able to achieve full flap deflection. And one of the exciting things to do is set the flaps at 45 degrees and just point the airplane down. Because of Mosaic, it's got a higher flap deployment speed, so even if flaps floor, you're able to go to that full speed, which is 92 knots. And you can just come down at 1,700 feet per minute, just aim straight, it feels like straight towards the ground in this aircraft.
There's so much gravity, you roll out, it just slows right back down to approach speed.
One of the things we had was a lot of separation on the first airplane. You put the flaps down, we had buffeting on the tail. You'll notice that if you fly a Cessna 170, 172 that has the 40-degree flap option, there's a lot of buffeting in the airplane. And we were losing a lot of lift due to separated flow from the flap tracks. So it's separated over the back. And you'll notice our center flap track doesn't have an upper track member. Those are pushed out to the ends. And as a result, we were able to keep that flow attached. Here's our flight test with good old yarn. And it remains attached all the way down to the end of the flap, the trailing edge of the flap. As a result, it's smooth, there is no shaking of the airplane, and we were able to increase the lift coefficient. So that 172 square feet of wing area that we started with, we shrank that to 161 square feet, which gave us more of that RV feel. The stall speed basically remained the same, within a knot. You notice the incorporated VGs on the back there. So those are punched by the punch press, they're slightly curved. Now all that curvature and the VGs are bent up, all that's done for you. You just take the skin out of the box, build it like any other RV. Your VGs are there, and they're not going to fall off. They're right integrated into the structure. Don't feel bad about taking your rag and cleaning the airplane. Your VGs aren't going to disappear. So just to summarize, increased efficiency, we were able to reduce the wing area. The stall speed basically remained the same, and there's no tail buffeting. So these flaps in the low forces, 1 to 3, forces are somewhat high, 3 to 4, unless you get down to a reasonable speed at which you would deploy flaps 4, which is about 55 to 60 knots. The ailerons, really quick, our main concern there was that we had enough aileron authority, especially when you think of a crosswind situation or being buffeted around in the air. We've achieved that. The aileron deflection is 26 up, 13 down. And to give you an idea, a super cub is 12 degrees up. So we have a lot more aileron authority. You're still able to fly this airplane around with the rudder like a cub. It has a lot of rudder authority, but you also have that RV feel. We wanted ailerons that were harmonized. That's part of an RV. You don't want to, go fly an airplane that has heavy ailerons and light pitch. It's hard to fly that airplane. It's not fun. It's fatiguing. We have a little strip that we do, or a trick we do, where I take pilots out that are new to the airplane, fly down the Willamette River, it's kind of curved, and say, was that fatiguing? Was it not? Were those forces too high? What did you think of the airplane? So that harmony and the control authority is what I want to get across, that I learned to fly in a J3. And you get in somebody's wake, you put the stick all the way over and you wait. And it will come back. I also, my building partner had a Cessna 182 310 horse, and we got caught in a rotor coming off onshore flow on a beach strip over the trees. And we had that airplane all the way over, and we're waiting, and it's continuing to roll over right above the runway, went around. This airplane, that's not a factor. It's just like an RV. Off-center, it's per the mission. You want them a little bit stiffer than the other RVs, but if you want that full deflection, it has more roll rate. I know you can see Van sitting over there. He doesn't even use all the roll rate of the airplane. But yeah, full roll rate, it's amazing roll rate. So just how does it fly? What have people said about the airplane? There's a number of phrases that I've collected from those that have flown it. Great flying airplane. Again, we have more time. I know we're ending a little bit early here, but I wanted to just allow ample time for questions as we work through this. So from here on out, it's question and answer period. Thank you. van make his way up here as well.
Do you have a question?
Oh, I was just gonna hog the mic for a couple minutes. I got there a little late. We had a board of directors meeting this morning, but it got over in time. Wanted to hear what these guys had to say. I just wanted to put in a plug for my two lead engineers here. They are superb. Part of that is one of the things that over the years I've claimed to be a stubborn Dutchman. That can be positive or negative, in the sense that you set a high standard and you stubbornly pursue that, it's a positive. These guys are way ahead of me technically as far as their math and their design skills, but they have that same stubborn quality of insisting that we get it right before you get it. So just wanted to say that. Go ahead with the questions and we'll do the best we can.
Stay up here, Van. You've had quite a few hours in the airplane as well. So I'll try to repeat the questions here because I know it's a large format. And here in the front. The question is, what are the quarter turn fasteners? They're actually screws. So the leading edge of the horizontal stab is removable. We anticipate that they'll get rock chips in it over time. It's an inexpensive part, and you can replace it easily. Yeah. Yes, the white shirt. Yeah, Brian, do you want to?
Yeah, so back to Van's stubbornness content, or comment. By the time we got to the end of the stabilizer.
What's the question?
Okay, yeah, repeat the question. Comment on the stabilizer to horizontal tail change. Why did we do it, and what's the difference? Now, by the time we worked through, I think it was 4 unique stabilizers and 6 or 7 gearing options, how the anti-servo tap works, we did end up with a stabilizer that flew fairly well, but it was never quite intuitive in your first few hours of flying or landing the airplane. So that always left somewhat of a question of, can we do better? Should we pursue the fixed tail? And we decided to pursue it with the intention, or with the plan that we can always go back. We can put the stabilizer back on it if we don't like what we found. And as we did pursue that horizontal tail, we found we did like the tail. It has less pitch authority, effectively less pitch efficiency for a given area going to the horizontal. We compensated that with a little larger tail, but it's so much more intuitive. Pilots can land the airplane, first or second try. It does what they expect it to do. Or with the stabilizer, it never quite got there. It was rate dependent. It was so big, it had a lot of inertia in it. If you gave it a sudden large movement, it would want to keep moving. You'd have to compensate. It wasn't 100%. It was in the high 80s, 90%.
Right. We got it almost there, but yeah, it was like flipping the light switch, because I was flying the airplane with people that weren't from vans, and I'd flown them with the stabilizer, flown them with the horizontal and elevator, and it's just like you turn on the light switch in a room, and you could see that they got it the first time out. And looking forward, we're anticipating this eventually going to flight schools potentially, and I wanted an airplane that you just intuitively snap there on the first. Other questions? Yes, sir. The brown. Yeah, the question is, what's the maximum size tire that you can accommodate? So first, I go back to the design philosophy. So, well, let's go why you want a 31 inch. We all know why we want 31 inches, because the other guy has 31 inches. We want to look as good as the other guy. So yes, it would accommodate 31 inches. But we have 6 inches of stroke, and with the 26s that you see it on right now, you actually have more effective stroke than, let's say, a 31 or 35. 35 might be close, because you're only getting half of the stroke out of half the diameter of that 31 inch wheel. The key to this airplane is the over-the-nose visibility. I can't stress that enough. And when you're able to see over the nose and see your spot, once you experience that, I'm not sure you'll want the 31s, because on 26s, the visibility is so good and the attitudes that you're able to fly the airplane. So yes, I anticipate people will fly with larger tires, but I don't think it's necessary, and you'll be able to plot better landings without it. But Brian, you designed the landing gear, so
The bigger the tire, the longer the takeoff roll is going to be in this airplane. Now, there's effectively 3 reasons to put the big tire on it. You're going to roll over a bigger rock, you need to get the axle higher to do it. You need to supplement the suspension of the gear with more cushion, effectively with these low pressure tires. Or you need to increase the ground attitude of the airplane to get closer to that critical angle attack. Effectively near stall where you have the highest lift coefficient. We've designed this airplane with the gear placement that is idealized and optimized for the 26s. We've designed the stroke that would otherwise come from the larger tire into the articulating main gear, and truly does really well on those 26s. They're lighter, they're lower drag, they're cheaper.
at 26 inches, you'll be able to maintain a constant prop diameter if you have floats as well. So we had that in consideration. So when you move the airplane onto floats, typically people switch their prop to a large diameter. I was talking to Hartzell actually yesterday evening about this, and they feel that the 80-inch we have on there will be sufficient with floats, but even if we went to 82, 84, you could leave that propeller on there, have these gear on there, and still have clearance with those 26-inch tires, or even the smaller wheels, and then be able to convert back and forth to floats. So, in the blue shirt, please. Flush rivets versus pulled rivets, full airplane. We'll give this one to Van.
No, you guys have a better answer on that than I do. When you get into drag calculations, and it's way above my pay grade.
At most, 1 to 2.
Primarily, though, that at the speed the airplane is going to be capable of, the flush rivets aren't going to benefit you that much. On our other airplanes, we don't know. We just put flush rivets on for various reasons. You know, they look better, it's easier to watch the airplane, etc. But
You will save 7 to 8 pounds on this aircraft to go to flush rivets. Or to go to solid rivets will save 7 to 8 pounds over the pop rivets. But, you know, at the end of the day, it builds so much quicker with the pop rivets. So
the flush riveting, we get into a kind of an argument here. Who likes to do dimpling on their skins? We're getting a lot of kickback. Man, it takes so long to dimple all of these skins and all of the ribs. Why can't you do that at the factory? Well, we're working on it. But here, if you want flush rivets, you're going to have to put a lot more work into it. And I know the question was not that. Your question was, what's the speed difference going to be? Probably, I wouldn't see more than 2-3 mile an hour maybe.
yeah.
It's the very leading edge of the wing would have an impact for the first maybe 20%. If it were flush, you could possibly maintain laminar flow. Behind that, you're not going to. So, one example, we look at the fiberglass wings. One of their big purported benefits was you can make them smoother, you can maintain a lot more laminar flow. A couple of years ago, AOPA had the RV-10 as a sweepstakes airplane. Along with the publicity, they went out and flew the RV-10 along with the Cirrus. Cirrus has got a nice, smooth fiberglass wing. They should have a lot more laminar flow, lower drag. Well, it turned out the RV-10 was the same speed as the Cirrus, even though we had 50 less horsepower. And they had this nice clean wing. Why? They had a leading edge on the wing for ice protection. The little disruption they had completely eliminated the laminar flow that they can get from that wing. So my only point there is it's not a direct correlation to the question here, other than that if you can't achieve the laminar flow, you might as well have the rivet bumps. They're not going to hurt you. Your boundary layer is going to be that thick anyway.
So the question was about the 15A, the tricycle. The 15A will come after the entire conventional gear tail dragger is released, but it won't be far after. To fully complete the fuselage and the fuselage testing, the 15A is going to be developed alongside for most of that.
Become the hard points for the floats in the back.
Absolutely. A very similar main gear.
Yeah,
And
we've had lots of requests for the gas strut. It
And I
might
did-
protrude up into your baggage floor, we don't know yet, but yeah.
And I did get a comment just to add to that. It is the same wing kit, so I just want to clarify that.
Right. Same wing kit, tail kit will be the same. Yes, sir. The 6x6, so the smaller tire size. We're trying to split the difference in there and try to get down into cub speeds as well. Yes, sir, in the green.
Could you see the Delta Hawk potentially being an option someday?
Sure, the Delta Hawk is flying on a 14, and to make the 15, we literally took the whole firewall forward off our 14A that you see out there, 214 Victor Alpha, and just unbolted it and bolted it right onto the 15, because we didn't want to flight test a new propeller and engine. So, yeah, the firewall forward for the 14, the only difference between a 14 and a 15 is the 15 will be a little bit deeper. Of course, because we have a deeper fuselage, because you have to have the structure on the bottom of the airplane.
But at course design, the power and the weight is compatible with this airframe.
Yeah, in the green. What was the question? Can you fill the barrel with water? No, that would be 8
All
pounds.
the way?
Yeah.
Not all the way.
What ultimately, if you're within the CG envelope, which we think is substantial here, you're going to be able to fly the airplane as long as you're in the gross weight and the CG envelope of the airplane.
And tie the thing down.
But if you fill it with fuel, it would be roughly the equivalent of a 300-pound passenger, so it's not that far off from reality.
Move to the forward place.
The question is about a four-place. I tried to explain that with my power slides. Really, power to weight ratio, you do not have a true four-place airplane on a four-cylinder engine. And originally, when we laid out this airplane, it was 2021. That was the beginning of COVID, 22. We didn't know where the market was going to go. And we definitely wanted to keep this airplane affordable. And a four-cylinder engine is a lot more affordable than six. And we, being vans, wanted to get an airplane out there to the most people possible. It also, this is part of the market that is dedicated to, it's kind of the middle of the market that wasn't covered, either by the smaller airplanes or the Cessna 180. So for four people, what happens in the future? You carry kids, I'm not going to comment. We aren't talking about that, it's just two people in baggage now. The reality is, though, that if you take a maul and go from the seat pan to the roof, it's 39 inches, and we're at 36 inches, and the Sportsman is 42 inches, and the Cessna 170 is 43 inches. So you're really limited in headroom in this airplane, because we want to duck down and get that drag reduced in the back and transform into the tail appropriately. So it's a little bit shy on real headroom. Yes, sir, in the black.
Are you designing your own floats?
Eventually, we'll design our own floats. Out of the box, probably, we'll just adopt somebody else's. But yes, we're a sheet metal company, and we fully anticipate having our own floats. The reason I wanted to build this airplane or design it selfishly was for floats. So I'm excited about that phase when we finally get there. But we're dedicated to getting the kit out the door right now. Other questions? Yes, straight back. Could you build it as a team flight airplane? I would say yes, it will fit within the Mosaic category. So it can be an ELSA. I'll stress again, ELSA, there's no 51% rule. Think about that. And you get an airplane with a POH, flight training supplement, a maintenance manual, a PAP, it's safer. The FAA wants it to go that way, and that's going to be a good option. You can still build an AAB as well. Are we going to pursue it as an LSA? As a company, we'll see where we go there. I'm sure we have that opportunity moving forward, yes. In the white. Okay, pitch, roll, harmony, and then stall characteristics. So pitch and roll is harmonized. Every time we make a change to one axis, we reharmonize it between the two. We have an opportunity to do that in the airplane easily in the fuselage. Even if we would have made a change now, we can still tweak that. So the airplane is very harmonious, and that's the standard that we want in an RV. So it does fly like an RV. It has more inertia, so it's not an RV-7, but it's very harmonized. Stall characteristics, again, we wanted that gentle stall. So some of you might have been watching the videos that have come out, and you'll notice you had a kind of a lurching stall brake. That's the worst I could get, and I was actually, kind of shoving the stick forward if you watch my hand in that video. That's the only one that looked like a stall on camera. Mark Cook looked and looked. So depending on your CG, it's really not a sharp brake. Again, Greg and I, we tried, because we wondered whether we wanted to put cuffs on the airplane. We felt that's unnecessary just because even stalling it with the ball off, you're still coming down. It's a gentle stall brake, and that's what you want in a flight school airplane. Eventually, it's also what you want if you're coming in trying to aim for that sandbar and you actually get too slow. You don't want a sharp brake. And the beauty of any RV, including this RV, if you feel it start to stall and you add power, you aren't losing altitude. So it has a great recovery, and that's part of the power to weight ratio that you want to keep and not have a underpowered foreplace. So, other questions? I'll let Brian take the next one.
Yeah. Can you spin the airplane?
Can you spin the airplane? Yes. We have not spun the airplane until final fuselage will come along, and we have talked about it with our test pilot, Len Fox, who spins a lot of airplanes. We feel it's not necessary at this time. It will be spun before we release the empennage kit, of course. The rudder authority in this airplane is substantial. I'm not even sure we need a larger rudder for a float plane operation. The initial rudder that you saw at Oshkosh the first time was much larger, the vertical in the rudder. So we decreased that dramatically, and we're not 100% certain why we have so much authority out of the rudder. Van and I have mused about that, but the fact is it's there. So yes, there's ample rudder authority in the airplane. Yes, we will be spinning the airplane officially to meet the spin requirements and pass the spin test requirements. And I expect with that rudder authority, it's going to come out. But spins are, it's very hard to predict. You can have an airplane that won't recover from a spin is because of the shape of the cowling. And so until we have that final fuse that stretched 1.5 inches forward and the wing moved back 4 inches, I can't answer that question on the final fuselage. But yes, now, yeah, you can spin the airplane. So the question is, where will the line of sight be after the 4-inch move on the wings? It's going to be better actually because the pillar is tipped back a little bit and you'll be able to more easily look around the front of the pillar. The leading edge of the wing after the wing move will still be a little bit forward from where it is in a car mode, yes. In the back, it's Mark, I believe. Go ahead, Mark. The question again was about the horizontal tail. Yeah, the leading edge is screwed on, so it's removable and replaceable. So, yeah, Brian, you're next in the back. Yeah, there's a blue shirt way in the back. We've been avoiding the back, so.
Some of the videos, it kind of looks like, Ryan, you're kind of looking through the wing. I'm wondering about your height adjustment.
Yes. Well, let's go back to the cushion photo. I purposely am putting myself really high, and Van does the same, where your head is up into the wing for that over-the-nose visibility. I love it. It's there. And the compromise is I have to look down. But when I just laid out the airplane initially, I put a person's eyeball right at the right underneath the lip of the door to get equivalent visibility of an RV-15.
Okay.
So I'm selfishly pushing myself up. I know Van loves the extra visibility as well. Brian, you can answer that one too.
No, I'm a little less particular than Ryan is. He'll grab all his cushion shims and put them in the right place. But the true answer is that, yeah, there is a ideal spot to put the eye, and we've designed an adjustable seat that you can adjust while you're sitting in it to kind of tune yourself into your preference. But that is an intentional thing that works itself up on the cushions.
Yeah, the final seat adjustment we're working on right now is easy to adjust, and so you can even adjust yourself up for landing, to get the view that I want versus the view you want in cruise flight.
Yeah, there's really no benefit to sitting lower in the airplane.
Right. Next question.
What's with the small tire and the new landing gear, would you be able to give us an idea of what to expect with the conventional spring steel gear versus the big tire? Like, what would you say is roughly the performance of the small tire versus the non-damaged one with the big tire?
So the question was to compare the performance between a spring gear, a leaf gear, and a big tire versus this gear and a small tire. And a lot of that, it'll depend on the airplane, how stiff the gear is. But the key here, that especially I noticed when I go fly other airplanes, is the damage rebound. So you can grease on an airplane and not notice a difference, really. But when you hit hard, and the event effectively just ends, it's not a dynamic return. I mean, the airplane doesn't roll one way or the other. It is completely different, and it's kind of something you'll have to experience to truly understand. But in a lot of ways, I think of this airplane like you're just distracted and you do something wrong, or we're doing it intentionally. Like, you never get to fit your stomach, like, how's this going to end up at the last moment? You just feel confident, like, well, we'll fix it on the next pattern. If we're going around, it'll take it, it'll go straight. There's no issue. Beyond that, we do intentionally kind of bring the airplane in and maybe less odd or more odd attitudes, or at a higher descent rate where we're not trying to finalize that final descent of the ramp out to flare as particularly as you would say in my Cessna. It's gonna bite you if you don't do it right.
Keep a few more questions going here. In the front row in the green.
Oh, 3 points.
3 points are easy.
Yeah. The wheel landing is effectively the same as any other airplane, since you're really just flying it on. But a 3-point is just super easy. You can nail it perfect, but you could effectively flare it too high, and in a lot of ways you just don't even notice it was too high. It just absorbs, tracks straight, it's soft. There's never been a teeth rattler in this airplane.
Yeah, I have been out with pilots start from vans and watch them wheel land the airplane. So it's pretty intuitive to pick up on the wheel landing aspect of it. Even though they hadn't had a lot of time in the airplane and all they've done was 3-point landings.
I will say, as far as using the wheel landing for really high crosswinds, I've never felt it's necessary in this airplane. Any of the other tail draggers I've flown, and even some that have very good reputations, like the Buster Sportsman, I'm much more confident in this airplane and haven't shied away from one or wondered or gone somewhere else. Like, this airplane has so much authority and you have so much control over it directionally. And knowing that it'll just track and you can easily just drop the flaps and it's totally settled down, and it's very confidence inspiring.
Other questions? Yes, center of the room there. Yes, that's you. Yeah, if you're not going to use it for a bush plane, and I kind of tried to talk to that a little bit on that first slide, but kind of hit it as well. So thanks for asking. It's a real use airplane, and it checks all the boxes. You don't have the top speed of the faster RVs, but the fact that I was able to come from Portland, Oregon to La Crosse, Wisconsin, in wherever La Crosse is, Wisconsin. Anyway, it's pretty close, and just a name on the map.
Yeah,
but it's a good town.
We do have a wheel pan designed, and
yes.
The production mold is partway done.
Well, let's tell the story about the wheel pan. Can we, Van? Van gets to tell the story about the wheel pan.
Now, first, I started business making wheel frames 70 years, a long time ago. So this kind of, I don't know, I call it my specialty. But here, obviously, the drag reduction features were secondary to everything you've already explained. But was gonna put a set of RV-10 wheel bearings on because they're big, but they're almost too big. And with this particular wheel, there was a lot of wasted space, so I had in my old shop, a wheel bearing laying there.
Let's explain how old the shop
40-year-old
was.
design or
The
whatever.
RV2 is sitting in that shop, so.
Well, whatever. Anyway,
This wasn't Van's house. This was
It
the
was-
barn where Van's aircraft started.
yeah, there was something, the bearing I'd made and sold many years ago, and actually it's a variation on that. It was made for 706, not a 606, so it was made for a little bigger than the standard tire. Anyway, I had that bearing, and we're going to modify it to make it a little tighter around the wheel, a little less drag. Didn't want to have to make another mold for that. I went back to the barn again. This is the barn out on the farm where we had our initial RV-3 factory. But, and there was a nail mold there, original foam fiberglass plug for that wheel. So it was just a coincidence that the only one of a couple dozen different shapes I'd made way back when was still there. So we've modified that, tried to make hopefully a little lower drag profile, and that's what they explained. We were in the process. It's not necessarily going to be the final, something we can get on the airplane, see what kind of a speed increment we can get by a cleanup process. And the wheel bearings, speed is not the only thing. If you fly off a grass field, your tires throw mud all over the place, whether it's a high wing or a low wing. So they have that advantage. On an airplane at this speed, we don't expect to gain a whole lot. You know, I wouldn't expect maybe 2 or 3 mile an hour at best. But the other benefits that come with it, the mud slinging, catching, whatever, and the appearance, obviously.
It looks good.
Yeah, everything on an airplane is
Shape.
everything on an airplane is streamlined except the wheels. If you make the wheels look streamlined, it's kind of a balanced appearance.
That's
Yeah,
it.
long answer to the question, but as Ryan said, it was just sort of a coincidence that we found these antique molds and stuff laying there.
And you're also focused, Van, on making that the quickest on and off. It's a single wheel pin, so it won't come apart in 2 pieces. It'll just lift off as a single piece. Fly to Idaho with your wheel pants, take it off. And those of you who haven't used the Airventure wheel system, the great part about it, you know, it took us less than 5 minutes to swap wheels when we were here.
Yeah.
Yeah, so it's easy to swap after you get there to the larger wheel set.
Anyway, it's kind of an incidental, but it's just one of the remaining things to work on.
It's a fun
And
story.
As Brian said, that trying to make something that is very functional in a case like this. He said, if you don't want to fly into the back strip with it, you take the wheel bearings off at the last fuel stop and fly the last 200 miles without them.
We're at the end here, so maybe 2 more questions if the first one's quick. We got one here and one in the center. So there's a hand up right back there in the center. Yes, ma'am.
Have you had any short pilots fly it, and if so, what was their visibility over the
Have we had any short pilots fly it? Well, have you seen my leg length? It's very short, and I replicate short pilots, so I feel your pain. Yes, that is a consideration. So we have had short pilots fly it, and there are some changes that will result from that. The neutral position of the stick will rotate a little bit further forward and be part of that instrument panel move. And we're still looking at further modifications to the rudder pedal that will come in the finished kit. But yeah, we're gonna have to go here. We're getting booted, so I'll take that last question at the booth. But thank you everybody for your time. Thanks for coming. Stop by,